Bismillahirrahmanirrahim. Welcome to the new class. Today we will discuss three different sorting algorithms. You will, in this class, you will understand the bubble sort, selection sort, and shell sort. And you can also see that why we have different kind of sorting algorithms. So the different sorting algorithms are have different algorithm complexity which we have discussed in very first class. So we will see that in different scenarios we have different algorithm complexity. That's why we have different sorting algorithms, and we have different application of these sorting algorithms. So let's start from the first one is bubble sort. In bubble sort, suppose you have any array of data. So it can be of any kind of data which you want to sort it out. So in this sorting algorithm, we start at the front, and then we traverse the array, find the largest item and move or bubble it to the top. So this is how the bubble sort is working, is like we start from very first element of the array, and then we compare it with the other elements, and then at the first pass we move the highest element to the right side of the, or you can say on the top of the array. So with each subsequent iteration, find the next largest item and bubble it up towards the top of the array. So this is how the bubble sort is working. It is also useful to look at suboptimal algorithms. So bubble sort is a simple algorithm with a memorable name and simple idea. So it's a very simple algorithm, but it is also significantly worse than insertion sort. In insertion sort, you already know that how the insertion sort is working, what is the time complexity of that algorithm. So this bubble sort is a little more complex than the insertion sort. So how we implement this bubble sort? Starting with the first item, assume that it is the largest. So we start from very first element of the array at index 0, and then we compare it with the second item. So this is how we implement our bubble sort. Like you compare the element with the adjacent element of the array. If the first is larger, swap the two. Otherwise, assume that the second item is the largest. We will see the example that how we simulate the bubble sort, and then we continue this process until we get the sorted list. So after one pass, like after one iteration, the largest item must be the last in the list. So this is the basic theme of this sorting algorithm, is that after each iteration, the largest element will move to the end. So start at the front again. The second pass will bring the second largest element. So after each iteration, you will get the second largest element, then third, then fourth, and so on. So we will repeat this process n-1 times. So after that, we will get the sorted list. So this is the algorithm. It's very simple. It's very easy to understand. Like yeah, you can see we can bubble sort list. We have any given list of numbers for all element of list. So we will traverse our searching from 0 or index 0 to the n. So if the list of I greater than list of I plus 1. So here we see that we compare the element at position I with the element at position I plus 1, which means we are comparing the adjacent elements. Then we swap. If that is list of I, like if the element of at position I is greater than I plus 1, then we will swap, because we are sorting our array in ascending order. So then we will end if we get the list is sorted. So this is how the algorithm is working. It's very simple. Now we see one example, and we will see that how we simulate it. So consider that this list is unsorted. This is unsorted, like 7, 14, 12, 33, 5 and 19. This is our list, and we want to sort it out. So first we will start from the very first element, 7, and then we compare it with I plus 1. 7 is I and 14 is I plus 1. So we compare. If I is greater than 14, it's not. It means that it's already sorted. So in the next we will compare it 12 and 14. So after this we see that the 14 is greater than 12, so we just swap it, and then we compare the 14 with 33. It's already in ordered. Then 33 with 5, the 5 is of course less than 33, and then we swap the element 33 with 5, and then 19 with 33. So at the end of first iteration, we see that the largest element 33 is at the end of the array. So in the next, this is our first loop. The largest element is in the last location. Now we will repeat this step, this process again, and after this we will see that we have the second largest element at the second largest position, that is 19, and so on. And the second iteration, third iteration, and fourth iteration, and at the end we will find this. We have this sorted list. So this is the way the bubble sort is working. Now we discuss about the second sorting algorithm, that is selection sort. First, you just see the algorithm that at very first step we set the minimum location, min, and like minimum. It's a short of minimum to location 0. We again start from the index 0 and we set the first value as min. We assume that this value is the minimum value. Then we search the minimum element in the list. Then we compare this first element of the array with each element of the array, and then we find the minimum value. If this minimum is not minimum, like this value is greater than some other value, we just swap with that value, and then we repeat this until the list is sorted. So this is again a simple algorithm. How it works: first we have the array of items. We have some list of numbers, that is the n size of the list. Then we see set the current element as minimum. So the current element is at position 0, and we call it represent it with I. So the first element will be the minimum. Then with j we set the j as I plus 1. We other than I, all the elements are j. If we compare it with list of j is less than list of min, like if j is less than the first element which we called min or minimum, then what we will do, we will just swap it. So now we see that how this algorithm works. So here we have the one example of unsorted sub array like 6 to 11, 7 and 5. Now at 0 at first step, we have I is equal to 0, like we are at first position, like 6, and we assume that this this uh, this is already sorted because this is the first element. At second step, we compare it with uh, we will find we start from 0 element, find the minimum element, swap it with the first element, and see in the whole array we have the minimum value is 2, so we just swap with the value 2. Again we will move to next and find the second minimum value, and we will swap it with 6, and again we will see find the minimum element, swap it with the third element of array, and then the fourth, the 7 is minimum, and the 11. At the end we will find that we will list it sorted at when I is equal to 4, because uh, we have the 4 elements. We have I starting from 0 to 4. So there is another way of selection. There is another way of selection sort. This is the same way we have already done. In the previous algorithm, we have set the min. We have set the minimum value, and we find the minimum value. In this example, we will see that we find the max value, the maximum value, and we will move it to the right of the array. So in this list, first we start from the 0, it's the same. So we will start at index 0, and we see which is the maximum value. So we see that the maximum value is, first we compare the 0, the value at index 0 with each value of the array. See, this is the comparison we are comparing, and we are going to find the maximum value or the largest value. Here we have the largest is 6. So what we will do, we will replace it with the rightmost element, because we want to sort in a way that maximum value is at the right. So the next 6 is sorted because we have already found the maximum value. In the previous example we have focused on the minimum value, so here we start from the max. Again we will find the maximum, and here we have the 5 is largest. We will swap with the second largest value, and we will swap it with the index at n minus 1. Again we will repeat the step, and 4 is already sorted, so no need to replace. Then the 3 is already in the sorted order, it's the maximum, so there is no need of swapping. Then 1, so we see the 2 is largest, so we will swap the 2 with 1, and this is how the selection sort is working different way. The last one is shell sort algorithm. This is little tricky algorithm, and it's a bit different than insertion sort, bubble sort, and selection sort. So this is not that difficult, but a little different how it works. In the very first step we initialize the value of h. What is the value of h? We will see it, and how we will calculate this value. Then we divide the list into smaller sublist of equal interval h. So basically the h here is the interval, and in this algorithm first we divide the array into equal intervals, or into equal sublists. What we will do again, then sort these sublists using insertion sort. So insertion sort, we have just gone through the insertion sort, and then we use this insertion sort to sort the sublist, and at the end we we get our list sorted. So uh, let's see that what is the edge. We also call it gap or interval. So first of all, at very first step we have seen in algorithm that we have to find the value edge or gap. So how we calculate? We use the formula, the floor n divided by 2. Here n is the number of elements in the array or in the list, and if we get the value like in decimal 4.5, 5.5, so we just use the int value or integer value. So here we have the 8 elements, and we find the gap which is 8 by 2 equal to 4. So now at first pass we have the value of gap or edge is 4. So we will keep dividing this gap at each pass, and the last pass when we have the interval of 1. So this is how the first step of the algorithm is working. Now we see from this example we have the same list, and we have divided n by 2, that is 4, and you can see that in this algorithm what is different is we are not comparing the value with the adjacent value, or we are not comparing the element with each element of the array. So this is interesting algorithm as well. Like we divide this array into a sublist and compare with the interval of 4. Like in this example, you see the first element is 35. We start counting from next element, like 1 is 33, 2 42, 3 is 10, and at 4 it's 14. So at the interval of 4 we have this element 14. So we will compare 35 with 14. Now the next element is 33. Then we again start counting from the next element 42, which is 1. Then 2 is 10, 3 is 14, and 4 is 19. So 33 will compare with the element 19, and so on. So we have seen that we have divided the array into intervals of 4 at pass 1. Now we will compare the elements. We will compare 35 with 14, 33 with 19, 42 with 27, and 10 with 44. So again we will see that because we want to sort our array in ascending order, so we compare 33 with 14, which is greater. So we know that 35 is greater than 14, so we will swap it, and 14 at the position of 35 and 35 at the position of 14. So 19 with 33 we will swap, 27, 42 we will swap, and 10 is already in order, it's not greater than 42, so it will remain at the same positions, and 44 as well. So this is our first pass output, and then we move to the next pass. In the next pass we divide n by 2, and now n is 4. When we divide it, we again find that interval of 2. 4 divided by 2 is equal to 2. So again we use the same concept, and we start counting from the next element, that is 19, and the interval 1 and interval 2 is 27. So we will compare 14 with 27, and then 35 with 42. It's the same concept. Like in previous slide we have divided our list into the interval of 4. Here we are dividing our list with the interval of 2. So after this pass we have the list. We have this list, and now we again find the interval, that is 2 by 2 equal to 1. Now we are at the end of this process, and we have found the interval of 1. After that, we use simple insertion sort algorithm. How it works? We know that we have compared with the adjacent value. If it's greater, then we swap. Otherwise, we move to the next. So at very first, we compare 14 with 19. So it's already in order. It's already sorted. So there is no need to swap. Then we compare to 19 with 27. It's already sorted. No need to swap. And then the 10 is less than 27, so there is a need of swapping. So first we will swap 10 with 27, then we compare 10 with 19, and then compare 10 with 14. So we see that 10 is smaller than all the values, and we move 10 at the first position. Then we move to the position 35 and compare with 33, and we see that 33 is less than 35, so we swap it. And this is how we get our list sorted. So this is a little different algorithm how it works. At the end it's the insertion sort, but at start we have seen that we just divide the list into a sub list, and then we get our list sorted. So these are the three algorithms we have discussed today. These are very simple algorithms, and it's very easy to understand. Try to simulate or try to run these algorithms by your own examples for your understanding. And it has a broader application when you're sorting some items in the database, or you are sorting any item in the array. So I recommend that all of you at least try your own examples, and if you have any question or if you don't understand, you may ask in a group, and I will answer you in the group. Thank you.